so what we are looking at today is just more of the same types of proofs, okay? So what I have up here on the screen, again, is that reference sheet that I really encourage you guys to make and to have on hand, so that way you guys can go ahead and be kind of following along and kind of using that to help you if you get stuck. So today what we're going to be looking at are just a few more examples, because again, our constant expectation is that we are continually growing in this concept. All right, we're still not looking for perfection right out of the gate, but we should be working towards that. So the very first thing here, if you notice that this has your statements or your conclusions given to you. So again, our very first step, always the given. All right, so that is always the case. So now if we look at this, what they did is they kind of picked this apart. So if we look at SQ bisecting the angle RQT, now if we look, SQ bisects this angle. And again, if we have an angle bisector, it's cutting an angle. If it's cutting an angle, that's giving us two angles. Okay, again, we use that analogy with the brownies. If you're cutting a brownie, you're getting smaller brownies. If you're cutting an angle, you're getting smaller angles. So again, what we have here is this word bisects. So this is just definition of bisects. And then we can go on and read that not only does it bisect that angle, but it also bisects angle RST. So if we look at RST, again, if it's cutting an angle, we're getting smaller angles. So now we're having these two angles here, which if you notice, that's exactly the two angles they named there. Again, they have to use three letters to name that angle because there's more than one angle at that vertex S. Again, as we look at this, it is the definition of bisects. And now, as we look at the information in our given, we've used all of it. So we can't get any more information. However, if we look at our picture, we have this shared side, and if we have that shared side, then we also have that it's congruent, which is exactly what they named here. And again, that reason is the reflexive property of congruence. And now if I look at my picture, I can say that I have my triangles because I got an angle here, and this side. That side is between those two angles, so therefore it is angle, side, angle. Now, something I didn't mention yesterday that as you guys are looking and growing in this, something to be mindful of is if you have angle, side, angle, what I would recommend is double check your proof. Make sure you have a pair of angles, got it. A pair of sides, got it. A pair of angles, got it. What that allows for you to do is not accidentally skip steps that you need to prove those congruent, okay? So let's look at one without any blanks given to us. So again, first off, number one thing is that we have JK parallel to LM, and we also have JL parallel to KM. Again, first step is always the given. Okay, so now let's look at our pieces. So again, I'm going to the given, okay? So in other words, always go to the given first to get all the information, and then go to the picture second to get some more information. So if we have JK is parallel to LN. Again, if we think back to our cheat sheet that we did, if we think about parallel, again, parallel doesn't give us congruent sides. Parallel gives us congruent angles. Okay, so as we're thinking about those lines being parallel, what we're looking for is the Z or N as a first possibility. So if we look there, we've got the angles tucked in at the corner at K and L. Again, I cannot name that with just one letter. I need three letters. So JKL is congruent to angle MLK. Reminder, if you're naming things, just go in order. So I'm going from J to K to L. All right? So again, those are alternate interior angles. Anytime we have that Z or the N, that is going to give us alternate interior angles. So alternate interior angle theorem, we can say those are congruent. Then we can go on to the next set of information. So we have JL is parallel to KM. And again, if I connect it this way, now I have the other pair at that corner. So again, I have to name it with three letters. Angle JLK is congruent to angle MKL. And again, because that's the Z or the N, we've got the alternate interior angle theorem that tells us that. So again, we use the given. The given, we have run out of possibilities as far as information is concerned. Now if we look at our picture, we have this shared side in the middle. And so now I can, again, I have to state it. I cannot just mark it in my picture. I would state KL is congruent to KL because of the reflexive property of congruence. Okay, so we see that shared side again. And now if we look at our picture, again, we've got the angle, and the side in between. So we can say using angle side angle that our two triangles that we're trying to prove, JKL, is congruent to triangle MLK. And we're done. Again, we know we are done when we get to whatever it is we are trying to prove. Okay? All right, let's move on to the next one. Okay, so while I'm writing this down, think ahead. What am I going to use to help get to these conclusions? So I'm going to write this and let you think. All right, so as you guys are looking at this, again, think about, can I get any information from my given? So if I look here, that's straightforward, okay? There's no words like midpoint or anything like that. I can come over here, BAC is in this corner, DEC is in this corner, and now I can move on to my next set of information. So again, C is the midpoint. So if C is the midpoint, what can we conclude from that? So we have to be careful, C is the midpoint of the AE. So if I look here, what can we conclude? Well, if C is the midpoint, we're going to get two congruent segments from that. So we've got here and here. Again, the word midpoint told us that. It's a definition of midpoint. And now that's all the information we can get from our given. However, we can look here in the middle, what's going on in our picture. And again, anytime you have intersecting lines like that, you're going to have vertical angles. And the vertical angles here are the two angles at that vertex C. Again, I need to go ahead and state this with 3 letters. So ACB is congruent to angle DCE. And again, those were vertical angles, so that is the vertical angle theorem. Again, if you just wrote vertical angle, that's enough. And now, if I look at my picture, again, I've got 2 angles. That side is between those 2 angles. And so if the side is between the 2 angles, it's also between the angles in the name. So by the ASA, I can say that triangle ABC is congruent to triangle EDC. Again, this tells us our congruent statement. We don't have to even pick apart the matching pieces like what we've had to do in the past. All right? Okay, hopefully this is all making sense. Hopefully you're starting to see some patterns. If we look at the next one, again, I'm going to go ahead and write this down. So again, be thinking about what is this going to mean for us. Okay, so let's take a look at this. So the very first thing when we look at this is that we have a bisector. So again, if it bisects an angle, we get small angles. If we cut a brownie, we get small brownies. All right, so if we look at this angle, we have the angle at the top, angle at the top. But again, if we mark it, we have to write it. We cannot just mark a picture without stating the conclusion, okay? So when we look at this, we have those two are congruent. Again, the word bisects tells us that this works, okay? Little disclaimer, you can't use definition of bisects or definition of midpoint if you're not told that it's a midpoint or you're not told that it's a bisector, okay? You can't just make it up and hope that it's true. All right, moving on to the next thing. If you notice, the next thing is straightforward. It tells us 2 congruent angles. So if we look, we've got the angle at W and we've got the angle at X. And now, if we look at our picture, we also have this shared side in the middle. And again, if we mark it, we have to write it. So we have YZ is congruent to YZ. Again, that's the reflexive property. Okay, I know it's a lot of writing. Stick with me. We're almost done with this one. And then here we have the angle, we have another pair of angles, and we have the side. Now the only difference is here, in order to use angle side angle, we would need this side, the one between the angles. It's not between. So since it's not between, it's not going to be between in your name. So it's angle, angle, side, and that's going to give us the triangle WYZ is congruent to triangle XYZ. Again, I got that information from up here. Okay, moving on to the next one. Okay, this one is a little tricky. There's a lot going on in our given. So I'm going to slide this up, give us enough space. So I'm going to go ahead and write these down. I'm actually going to write them down a little bit differently, just kind of stagger them so we can kind of see what's going on a little bit clearer rather than one big long line. So again, all I'm doing is just copying down my given. Okay, notice I'm not just circling it and drawing an arrow. Don't do that. People do that in the past. Don't do it. Okay, so let's go step by step. So first off, if we look here, there's no extra information to get from that. What it's telling us is we can just come over here and we can mark it. If we look at the next set of information, we've got parallel lines. So if we have AB is parallel to CE, again, if we look at this N, we're going to get an angle that's outside the triangles. We don't want that. But instead, if we look at the other transversal coming through this way, we have angles in the same corner of those intersections. So again, I'm going to come over here. Step 2, right angle BAC, that's the one in the lower left, is congruent to angle ECB. And the reason, those are not alternate interior, those are corresponding angles. Again, it's a postulate, not a big deal if you don't have the right word postulate. Corresponding angles is the important part. And then we have this part. C is the midpoint of AD. So if I look along this line down here at the bottom, C is the midpoint. So if C is the midpoint, again, if we have a midpoint, that's going to give us two congruent segments. So we have AC is congruent to CD. So we've got this part here is congruent to this part here. So again, the word that told us that was possible, definition of midpoint. And then from there, we look at our picture, we have two angles on one side. The only question is it angle, angle, side, or angle, side, angle? So as we look, the question is the side between our angles? If we look at our picture, it is not, so therefore it is not in our name either. So triangle ABC is congruent to triangle CED by angle, angle, side. All right, last one. Here's the deal. If we look, I'm gonna do what I told you just not to do to save me a little bit of time in our notes. But please rewrite those. Don't just do what I did. Okay, I'm gonna say that again. Don't do what I just did. I'm just saving us some time because I know this notes video is getting lengthy. All right, so the first thing, we're gonna pick it apart. So if it's a right triangle, we can go ahead and just kind of keep that on the back burner. I'm gonna kind of hold on to this. I'm gonna kind of put this in brackets because we're gonna come back to that. The next set here, this part, WV is congruent to YZ, so we can go ahead and mark that, boom. And then we also have this midpoint piece here. If X is the midpoint of WY, I can say that this is congruent to this. But again, if I mark it in my picture, I have to write it, okay? Don't just mark it and leave the reader to figure it out. Again, midpoint, so definition of midpoint. Now, here's the thing. You technically have angles going on in the middle. However, if you mark those angles, you have a situation where it is side-side angle, and that's one of the ones we cannot use, and we cannot use angle side-side. However, if we come back to this information that we were given to begin with, if these are right triangles here and here, now we can look at our picture and we can see that we have the hypotenuse and we have the leg. So by HL, we could say that triangle WVX is congruent to triangle YZX. Okay? So as you guys are looking at this, if you're using HL, you need to have that they are right triangles because that's the only time HL works, is if you have right triangles. All right, guys, I know that's a lot. I know that's a long video. Hopefully you're understanding. Hopefully you're starting to see patterns. Again, if you need help, please don't hesitate to reach out. I'd rather you practice things right than just kind of fumble along and practice things incorrectly. All right? Let me know if you need me. Thanks.